So for what I wanted to talk about, I wanted to do a little bit less slides. If you've seen any of my talks, I like to do whiteboarding. I like to be a little creative on a lot of things. And so I wanted to focus on the story that I've kind of experienced from what I'm calling this talks container to cloud, and really about like that initial experience with what containers were to me and how I was using them, and then how we kind of got to this cloud point of what it meant. And oh, my wife has been learning Welsh. I don't know if anyone is here from Wales, and I'm trying to. Oh, I wrote it down and now I can't find it. It's a wait, Prin. No, I'm not. I'm gonna butcher it. I can't do it. Justin do I am Justin. I don't remember. I'm sorry. I was gonna try to do it and it just didn't work out. But anyway, so my first. Oh, thanks. Wales is here, so we are learning. My wife's learning Welsh, and yeah, I'm learning Japanese actually from this whole pandemic, and so it's just like I don't know if you can get two different languages, and so we still can't communicate. Sweet, I got something right. Anyway, so my story starts here with kind of when I first experienced Docker, and this was mid or late 2015. It was kind of an afternoon, and I was at work, and I saw this thing called Docker pop up. Probably Hacker News, might have been some RSS feed, and I was like, okay, what's this thing? Let's figure out how this Docker thing works and what it does and why I might want to use it. And so, of course, I curl to bash the installer, because that's how you installed it. Yes, I got it right. Thank you everyone for the letting me know. That's awesome. I curl to bash the installer, and it did something on my system, right? Like that's how curl to bash works. And of course you have to give it sudo access. But like, what did that do now? Like, what is this? How do I use it? And the basics for understanding like Docker is they have you run this hello world, right? And that's the command everyone kind of starts with. And I'm sorry, I moved my mic. It's right next to my keyboard, so it's really loud when I type, but it sounds like I'm doing a lot of really hard work. Hello world. All right, like that's the command that so many people start with. And it's just like, okay, well, that just gave me a bunch of other instructions of things to do. And if it's just like printing text to my terminal, like I could do that with bash. Like do I need this Docker thing? Like I don't understand the value I'm getting out of this, because it seems like a bash script. And I probably just want to use bash in this case, because that's my first thing that I often do. But let's dig into a little bit more. Let's figure out like, okay, how is this actually working? I hear some people using this. Let's try this command, right? They give me an example, so maybe I should just use that. Okay, now it's slower. Like, okay, now this command isn't. I don't think I like this Docker thing, and it drops me here, and I'm like, well, great. It broke my prompt. Like that's not what I wanted. Like, why is it this weird jumble of letters now? Like my prompt is completely broken. I don't understand what this did. Now what do I do? And that was kind of my thought this first time I'm using Docker. And it's just like, I don't get it. I don't get what the hype is. I don't understand what I'm doing. But then I start realizing that Docker's actually making something really complex, really simple. The more I use it, the more I'm realizing, oh, this is actually taking something like namespaces and C groups and taking tar files, right? Like tar files aren't actually that complex, but it packages them in a way to make it simple for me to use and to just get started with. And so like, that's really how I started finding more value out of, okay, if I can make this complex thing simple and repeatable, there actually might be some value in there. So the whole thing with Docker starts here with a container. Like that's like, most people are like, well, the containers are this. It's a tar file. So I was like, okay, well, my next step is I need to make a container. I need to figure out what it is that I need to do to actually like build my own. So if you're familiar at all with Red Hat or Yum, very first thing I do is yum list, pipe that to a Docker file. If you know what that does, that lists every package you have installed on your system out to standard out. And so I could take that and I could just say, well, let's make a Docker file. Like this is Docker files, what I have to do, make this container. And there's a problem here. Like this was simple. I got started. The problem was my very first container image was 60 gigs. Not even joking. It was actually a little over 60 gigs. And I was like, okay, maybe I'm not using it right. Because this probably is something that I wasn't supposed to do. But it worked. And okay, now I can start to understand how this could be useful for me to actually do something else. So the next thing, like let's build some more of these things. Let's build some more. Oops, not actually what I wanted. Let's build some more containers. And so Docker, again, takes this complex thing and makes it simple by letting me reuse things, by letting me say, oh, well, actually, you know what? Like the complex things that a lot of people were doing is trying to figure out runtimes for their applications. They're trying to figure out how to, get some runtime into their application and not worry about the system. So I can say like, oh, from Python. And that's actually really simple. That interface for me to say like, oh, well, like I actually want to use Ruby. And those things started to grow, and I started finding all these cool containers that I could build off of. And I could say, oh, well, actually, like I want to use these things. I want to do this more because this is easier than building RPM spec files. There was a big problem there of trying to figure out, something that was not a standard. And I mean, spec files were, but like not consistent across systems, and saying, okay, well, like, how do I package this stuff? And the problem with this was I started running all enough. About 2 weeks later, my hard drive was full. I pulled every container from Docker Hub practically. I said, well, let me see what this one does. And just, I kept pulling them out. Okay, like actually there are some limitations here, and there's some things that this can still break. But that doesn't mean it's not useful. So I start showing some people, and I start saying, hey, like this container thing, like let's try to package your application in a container image. And then we'll see what we can do with it, right? And so just like we had VMs growth, like proliferation of VMs, we had the same thing with containers, right? And everyone wanted their own container, and they're like, oh, we're going to build this ourselves. We're going to run it. And then because they don't know some of those limitations, they don't know some of those gaps, they fill it with junk. It's like everything is like, oh, well, like my application needs all of this. And so I'm just going to throw it all in the container, and that's how we're going to work. And it was fine in a lot of cases, but these containers weren't the only thing that Docker was doing. This wasn't the only benefit we were getting out of this. So another thing that we actually got from containers was, as we were shipping this to production, we had to upgrade Docker at some point. And if anyone is running Docker early on, you probably did it, and you're like, oh, actually, you know what? Like Docker upgrades were scary because it broke and containers didn't work anymore and production went down. And that was really scary. But thankfully, we were able to do something with that and make it better for everyone by building a standard. And so we could take all these container images and we could make it OCI came. It's like, oh, wow. Like this is actually like a thing I can rely on now. Like these bunch of tar files and metadata are something I can rely on and run in production. And because of that spec, it actually grew a lot more. We wouldn't have got some of the other things we have now without having a base layer spec of this is what a Docker container is. And so now we have things like Helm charts are Docker containers. We have CNAB bundles are Docker containers. Dan's going to show you another demo with some unique use cases of Docker containers. And we can rely on that spec as saying, hey, like this is actually a valuable thing. Like these tars are useful for actually running production systems. But again, not the whole story. Like we had to go from that and now actually like run it in production. And what we used to do early on was we had Puppet or Chef config management, configuring all these systems, deploying systems, VMs, physical systems, whatever, to make them usable for someone. And a lot of times it was like, okay, here's your VM, go pull your repo and run Apache or whatever. Now with these containers, we use the same artifact, the same technology, and we pushed it into our old workflows. And we said, oh, well, let's just use Puppet with some tags on a host, right? With some metadata about the host, and it'll run a container. And now Puppet is our interface to run those containers. So Puppet's doing the Docker run and making sure a container's running. And that's simple to get started because we understood the complexity of Puppet, but it wasn't simple for running at scale. Like Puppet does a great job, Chef does a great job at running systems at scale, but running the applications on top of those systems, the abstractions didn't really line up. And we ended up with a lot of mismatched complexity of, hey, how are we actually doing this? And so we needed a better interface for how do we do Docker run at scale? How do we get that sort of piece of like, fetch the container, do this thing, and now run it? And of course, everyone probably watching this knows the story, right? I have practiced that so many times, and it's still not good. It's like the hardest shape to draw, I swear. So Kubernetes, like there were things before, there's things that still exist. There's Nomad, there's ECS, there's Swarm, there's Mesos. Like these things exist, and these things are still there, and people are still using them for great use cases. Kubernetes really kind of found a balance between it can do Docker run at scale. And a lot of people, like there is still complexity involved. It's a new complexity for a lot of people because we traded these Puppet manifests or Chef cookbooks. We traded those for a distributed database and an API. And those things are actually different, especially for people running systems. People that ran systems aren't used to that complexity. And so they say, okay, how do I make this piece simple? And that simplicity, in a lot of cases, just comes from like managed services, right? EKS is a way to run Kubernetes in Amazon, and you don't have to worry about the distributed database and the API server and all that stuff. Like Amazon, we handle that for you. And it's a great way to kind of just like, okay, well, you can still run some of that at a fairly simple, scale or fairly simple interface, and reduce some of that complexity and simplify it for the user of the service. And we can say, okay, now we can actually do some more things here by reducing that complexity for you. Kubernetes came along, and like Docker container usage, that's a hockey stick up since then, right? Like containers were a thing before, and then Kubernetes made that consistent and reliable, partially from that OCI spec, but also partially because Kubernetes was able to rely on the OCI runtime. Another spec from that group saying, hey, like actually this is important too. Runtime is important, and we need to take that into consideration as a spec so that more things can build on it. And Kubernetes, is able to do that because this exists. And the third piece of complexity that containers and Docker really solved was workflow complexity. Say, I want to take my container image, and before, developers had all sorts of mixed bag of how do I ship this code? How do I make this thing work? And now it's build a container, push it to a registry, pull it down. That's it. It's repeatable. That is how we're able to do this. And that workflow reduced so much complexity. If anyone wasn't doing this before, like that, it was a nightmare before of like which application deployed where, how is their build tooling, how does this work, where does this code live, where's the Git repo, all that stuff was complex. And those are the things. This is brand new spec from OCI called the distribution spec. And distribution, bad handwriting there, sorry. But that is this workflow. It actually is a standard for the registry on how we're pushing and pulling images to registry. So now that distribution can be relied on and built on top of. People have obviously been running repos beforehand. It's not a new thing, but it hasn't been a standard until 2 days ago. So here's the other piece. Now people want to take this same thing and they say, well, you know what I want? I want this same workflow and I want to go to the cloud. Like that's the thing that a lot of people want. And they say, well, you know what, like how do I get that thing and just make it go? Because Kubernetes, if you're running it there, great. You can manage that stuff. But for the simple things, for simple websites, for things that aren't complex, if you want it without all the YAML, there are ways to do that. There's hosted services. There's ways we can do that. And I built a little tool here just to kind of show like what I think of when I say, hey, this doesn't need to be complex. And it's just it's a script. It uses standard services and it has the same Docker workflow essentially of, hey, I want to run something. Here's my container image and let's give it a name, right? Like, let's say I actually want this to be a published secure endpoint on the web. Like I want to be able to just hit this endpoint later. That's my name. Figure out all the complexity. And I can actually take that package container image. Oh, don't tell me it's going to break. I actually think I didn't delete that endpoint. So of course we're going to go complex 2. Because that's what you do. You just increment 1. Let's make sure this gets started this time. But this is the workflow that a lot of people loved with Docker. And this is the reduction of all of the complexity of C groups and tar files and everything else that people had before of saying, hey, you know what? Like, do I need that? For simple things, no. For complex things, Docker Compose exists. That was made. You write some YAML, you integrate some things on your local system. You maybe go do that on a server. For cloud is also a complex thing. There are a lot of tools and a lot of services and a lot of things that exist that make cloud kind of complex. And we say, okay, well, let's simplify this. Can we zoom out from the cloud and get just the pieces that I actually want for run a container? And these things exist. Kubernetes obviously solving that for the complex things, and in some cases solving it for the simple things, depending on how you're accessing it, how you're running it. But this last piece here of, okay, let me simplify how it looks in a cloud environment. That's the tooling that I think a lot of us as developers, whether we're developing systems or we're developing applications, if you're a systems developer, you're trying to simplify this for your developers, for the people using your systems. If you're an application developer, you're trying to simplify this for your users. You probably have a mobile app, a website, spreadsheet, something that makes someone else's life better, hopefully less complex. In some cases, complexity is needed. I'm not saying like just get rid of the complexity. Absolutely, like if I'm debugging a system, I need more information. I need to understand the details underneath it. I need the complexity to be shown directly to me so I can figure it out. But in a lot of cases, some of these standards allow us to focus on just the simplicity of how this could work. So when I look at this and I actually zoom all the way out, go. This is how I like to think Docker impacted a lot of this stuff. It made a lot of these pieces and put them together in a way that we could reuse them. It reduced that complexity. And I'm giving props to them for figuring out how to make those complex things simple in these 3 areas, especially in those workflows, in that standard of a packaged format that we can run and in a runtime that we can rely on to build systems on top of. And if I switch back here, it's almost there. Again, hiding complexity is okay. Some of it's automation, some of it's abstraction. That's okay, actually, as long as we give a simple interface that someone can rely on and build on top of. Those are the things that we actually want our users and our other developers to be able to build on. So sometimes we lose some of that noise for like, I need more Kubernetes or I need more controllers. And some of those things we just say like, hey, let's focus on the simplest thing that you can use. Hosted services, something external, and make that repeatable and reliable for you. Those are the things we really need in our own systems and how as we're building things. I swear this is going to work. but really, like, I just want to focus on that of like reducing this complexity, the container image, how the container was able to make some of that stuff. Like if anyone else extracted a container image, as tars, like, okay, I understand the layers, I understand this metadata, linking those things together. In Kubernetes, we can actually do a lot of the same things. We have controllers that link together. It hides some of the complexity. When I make a deployment, what that actually does is it interfaces with 3 different controllers. It automates 3 controllers together. It says, okay, well, here's my deployment controller that's going to build me some replica sets. Those replica sets are going to create pods. Those pods are going to get scheduled. And so I have these different controllers that interact together to make complex things simple as an interface. And so definitely keep focusing on what makes things simple for an end user and for anyone that's using your systems. And hopefully this is actually running. Yep. There it is. There's that workflow. That's what we wanted, right? We ship those containers to something simple that looks like it runs in production. And it doesn't actually matter in some cases if underneath the hood is something a little more complex, something that someone has to figure out, but in each of their own little areas, they can simplify it for themselves. They can understand, oh, actually, I just run this load balancer piece. I just run this ingest piece for traffic. I just run these Kubernetes bits. And creating all those complex things into something that's simple is really the goal for a lot of our systems. So I'm encouraging everyone, don't throw away the past, but look at how we can build simple things on top of these complex systems and giving people that interface in the workflows that can simplify for everyone.